Hi, today I'm going to talk about the oxidation. So let's start. First, um, we can see the locus of oxidation. Locus means local oxidation of silicon. So if we make an oxidation, we can get a result of that waveform. Um, when you look this picture, you can know how the oxidation process going on. So first, on the silicon wafer, we can, if we want to grow oxide on the silicon wafer, we can do this oxidation to grow oxide on the silicon wafer. So if we grow oxide on the silicon wafer, we can get a result of that process. Silicon, we want to grow a silicon on the silicon. We want to grow oxide on the silicon wafer. However, some of the oxide can be grown on the silicon wafer. However, silicon oxide is made by silicon and oxide, so that oxide also consume the silicon too. So ideally, if we grow the oxide on the silicon wafer, a clean silicon wafer interface, and just only oxide will be grow on the top. However, actually we can get the result of the oxidation. If we check When we check that result of the oxidation, the silicon wafer, some part of silicon wafer will be removed, and then oxide consume that silicon also. So because of that, silicon oxide will be made like this shape, and then also in the bottom side, we talk that part like we called it bird's beak because it looks like a bird's beak, so we called it like that. Then let's talk about the process and the type of oxidation. We can make a shallow trench isolation and deep trench isolation by the oxidation. So in the chip, we want to draw many circuits on the chip. So if to operate those chips very well, to work very well, the isolation is very important to the chips, between the chips. So we can make an isolation part by oxidation. So we called it shallow trench isolation and deep trench isolation. There are two types of isolation process. And also, before we do the oxidation process, we should make the wafer clean state. So we do CMP process. So let's talk about the CMP process more. A CMP means chemical mechanical polishing. So it means polishing too. So we should clean the wafer to do a next step process. If we don't clean up the wafer, we can do the process on that wafer, but the result will be very poor. So if we want to make an exact result, if we want to get an exact result of our process, we should clean the wafer very importantly and the next step. So CMP is the most important step of the oxidation. So let's see how that CMP works. First, we put a wafer on the machine, and then we put some slurry liquid. It is like kind of cleanser of wafer. So we put some slurry liquid on the wafer, and then this polishing head spin a lot on the wafer. So it works same like our lifestyle, like kind of car cleanup or yes, kind of kitchen machine. Yeah, so we can, if we want to polish something, it works like this same too. So polishing head makes the wafer very clean state. So after polishing, we can get very clean wafer. However, it has also problem, like dishing issue can be happened after CMP. Dishing means if we polish something, some part can polish very well. However, some part can be polished more than other parts. So it looks like hole on the top. So this pattern can be made by CMP because some part removed more than we want to remove. So those parts we called dishing. So let's talk about the summer oxidation. Summer oxidation, if we do summer oxidation, we can grow the silicon oxide on the silicon wafer. So at first, I talked about the silicon growing. So if ideally silicon oxide will be grow on the clean silicon wafer, and only growing can be happened, but actually silicon oxide consume the silicon, so it makes some hole, and also that hole will be full by silicon oxide, so it is bold shape. So summer oxidation after we do summer oxidation, we can get that type of shape. So this picture can show that result of summer oxidation. So this is the fin fat, and the gray color, deep gray color, means a silicon wafer, origin silicon wafer, and this light gray color, the line of the light gray color means SiO2, just we call silicon oxide. So after we do summer oxidation, we can grow the silicon oxide on the silicon wafer, origin wafer, and then if we do more process, so on the top of the process, on the top of the silicon oxide, we can deposit or something grow the gate material too. Then oxidation has two types, so dry oxidation and wet oxidation. So first, let's talk about the wet oxidation. Wet oxidation means we do the oxidation by water or some liquid chemicals. So for example, if we do wet oxidation by water, if that silicon and water meet, and oxidation after, then we can make a silicon oxide and hydrogen gas. So wet oxidation works very fast and it is very simple. However, dry oxidation is very slow because it uses gas. It uses oxygen gas. So the process works very slow. But however, after dry oxidation, we can just grow the silicon oxide only, and no byproduct will be made. Also, if we do the dry oxidation, we can make a very dense material, and the dielectric breakdown will be happen more or less than wet oxidation material. So dry oxidation has a lot of positive things, but that process works very slow. So oxidation cost is very high than wet oxidation. So if we want to draw a very specific and small pattern, we use dry oxidation in that case. So I compare with dry oxidation and wet oxidation to this paragraph, but yes, actually I said it before. So just dry oxidation material has more high quality than wet oxidation material. So if we do the oxidation, the gas pressure is also very important to do that process, because gas pressure also influence to our wafer process. So there are some trade-off happened. So if the 1 atm changed, the temperature will be changed like 30 Celsius. So it has trade-offs, so we should change the specific parameters to make more high quality wafer chips. So we should know about the trade-off characteristic to do our process very well. Lastly, let's talk about TEM. It is transmission solution microscopes, electron microscopes. So if we want to check the interface or surface of material, we can use this machine to check the interface. So this is the TEM image of some material. So this is the interface, and we can check the characteristic of interface in here. So in the middle side, there adhesion or something else is not very good in this material. So if we check when we check that problem or trouble, we should find a solution to solve this problem and fix and then change our process parameters to make more better wafer to work well. So yes, that's all. Today we talk about the oxidation process. So thank you for watching my video. Bye.